In this video clip we're going to look at the Schmitt Trigger circuit. This Schmitt Trigger has been constructed using an operational amplifier, and we're going to assume that we're dealing with a perfect operational amplifier. The inverting input is connected to this potentiometer VR1, and the non-inverting input is connected to this combination of resistors. These two resistors they're all identical, are three resistors, and because the inverting input Vin is currently at 0 volts, the output will be at 15 volts. Now, because the output is at 15 volts, this point in the circuit where this resistor is connected to the output of the op amp is in effect connected to the plus 15 volt rail. That effectively puts it in parallel with the resistor here. So in other words, the combination of these three resistors form this particular configuration, and that results in 10 volts appearing on the non-inverting input. Let's now consider what happens as we raise the potential on the inverting input. We raise it from 0 volts and gradually, using this potentiometer VR1, raise its potential to 15 volts. We'll plot the output V out against the input voltage V in on this graph here. So because the output is currently at 15 volts, it remains at 15 volts because at the moment, because the potentiometer has now been moved up and it's now 2 volts on the inverting input, but that has not reached 10 volts, so therefore the output is going to remain at 15 volts. And this continues 4 volts, it's still below 10 volts, so the output remains high, 15 volts, 6 volts, 8 volts, and we eventually reach what we call the upper threshold voltage, which is 10 volts. When we reach the upper threshold voltage, the output voltage suddenly drops from 15 volts to 0, because now the inverting input voltage is exceeding the non-inverting voltage. Now the effect that has on the circuit, on the combination of these three resistors, is such that now the output has dropped to the lower voltage 0. This resistor, or this end of this resistor R, is connected in effect to the 0 volt rail, and that creates a combination of resistors which looks like this, with the bottom two resistors are now in parallel with each other, and the top resistor here connected directly to the 15 volt rail. Now this combination of resistors with a 15 volt supply across it means that we get 5 volts now appears at the non-inverting input due to this combination of resistors. Okay, so we now continue to raise the voltage on the non-inverting input above 10 volts, 12 volts, right up to 15 volts, and because this is above the non-inverting voltage, 5 volts, the output remains low. Now we're going to reduce the input voltage. We're going to bring it back from 15 volts back to 0, and we're going to look at what happens to the output. So at first 13 volts, 12 volts, 10 volts. Note this time that we've come back to 10 volts, but whereas 10 volts before was enough to trigger the output to swing from plus 15 to 0, it's not low enough to swing the voltage from the output back to 15 volts, because the lower threshold voltage, which was being created now at the non-inverting input, is 5 volts. In fact, we have to lower the voltage right back to 5 volts until we have a voltage which is sufficient to cause the output to swing back to 15. And as it does that, you can see how the threshold voltage has now also changed at the input to the non-inverting input it's changed back to 10 volts. When we go back to 2 volts and eventually back to 0 volts, you can see that the output of the circuit stays at 15 volts. So in effect, this circuit exhibits what we call hysteresis. What that means is that we have a different voltage switches the output from high to low than the voltage which switches it back from low to high, and hence we get this Schmitt Trigger type characteristic shape, which you often see written on components to note to signify that the circuit is behaving as a Schmitt trigger.